Hello students, welcome to my channel I Smile Academy. Today we will be doing atoms and nuclei part 3. The first question, in Bohr's model of hydrogen atom, the lowest orbit corresponds to infinite energy, maximum energy, minimum energy or zero energy. So we'll draw the energy levels first. So this is the energy level n equal to 1. Okay, let us take this n equal to 1. Okay, then this corresponds to n equal to 2, and then n equal to 3, and so on. We can draw more. Okay, now the energy equation, as we know, En in general, the energy of the nth orbital for the case of hydrogen atom is given by this equation, minus 13.6 divided by n square. For n equal to 1, n square becomes 1, so this corresponds to energy minus 13.6 electron volt. Of course, it is electron volt. I am not adding it here. So for n equal to 2, what we have minus 13.6 divided by 4, because 2 square is 4, so it comes out to be round about minus 3.5. okay, this will again 9, so this is again 9, so it will come out around 1 point something, 1 point, let us take as 1.4 something. Okay, so what happens as we go up, as we increase the levels, okay, as we increase the orbit, the energy goes on increasing. Why increasing? Because actually we are in the negative sign. Okay, minus 13.6 in the second orbit becomes minus 3.5, so it has increased, because minus 3.5 is greater than minus 3.6 if we take the negative numbers, negative sense. Okay, and minus 1.4 is greater than minus 3.5, so this is the lowest energy. Okay, so the lowest orbit corresponds to the minimum energy. Okay, and as we go up, the energy increases. Next we come to question number 2. Which of the following statements about the Bohr's model of hydrogen atom is false? So remember what is asked is which statement is false. So we go one by one. The first statement, acceleration of electron in n equal to 2 orbit is less than that in n equal to 1. Okay, so we'll find the acceleration. Okay, now we have this acceleration. Okay, a, okay, is given by a is equal to v square upon r. Okay, a is equal to v square upon r. So where v is the velocity and r is the, of course, radius of the orbit. But what we have, v is actually proportional to z upon n, where z is the atomic number, n is the orbital number, that is n, principal quantum number. And we also know that r is proportional to n square. Now if we substitute this both here, so what we have is a would be proportional to instead of v square, because it is v square, so we have z square upon n square. Okay, and in the denominator we have r. Okay, and r is proportional to n square, so one more n square because of this r. Okay, so you must remember this one, this is because of the velocity, and this part, the other one, okay, this one n square is because of r, this one is because of r. Okay, because of r. So what we have is finally a is proportional to z square upon n raised to 4. Okay, so as n increases, a decreases. Okay, so in the given question, acceleration of n2 is less. Of course it is less, because n1 the acceleration of n1 is greater than as compared to n2. Okay, so first statement is right. We want to find the wrong statement. Okay, so this option is gone. Now next, angular momentum of electron in n equal to 2 is more than that in n equal to 1. So what is the expression for angular momentum? So angular momentum according to Bohr's theory is nh upon 2 pi. Now see, n and h, these two are constants. Okay, these two, h is Planck's constant and 2 pi is of course a constant number. So n, as n increases, angular momentum increases. So for n equal to 2, the angular momentum is larger than n equal to 1. So again this statement is also correct. Okay, see, so this statement is gone. Why it is gone? Because we want to find the false statement, and this is a true statement. Okay, then number C, kinetic energy of electron in n equal to 2 orbit is less than in n equal to 1. We know this kinetic energy, it is proportional to 1 upon n. Okay, kinetic energy, if you observe this, we have done in previous videos that kinetic energy is proportional to 1 upon n. So as n increases, the kinetic energy will of course decrease. So kinetic energy n equal to 2 is less. Okay, so even this statement is gone because this is a true statement and we want to find the false statement. Now last will be, of course, last has to be false statement. Okay, let us see this. Potential energy of n equal to is less. We know potential energy, it is proportional to minus 1 upon n. Okay, so as n increases, okay, p also increases. Okay, and what is given here, because it is minus sign, therefore as n increases, p also increases in the negative sense. Okay, so potential energy of electron n equal to 2 is less than n equal to 1, which is false because n equal to 2, potential energy of n equal to 2 is more. Okay, so this statement is false. Okay, but why I'm writing right, because we want to find the false statement. Okay, so this is the statement. So here it is a very rich question. We have solved in fact four problems together in one single problem. Okay, so this is the correct answer. Now question number 3, which of the following transitions in a hydrogen atom emits photon of highest frequency? So we know this energy of an electron, energy is given by E equal to H into F. Okay, so what we observe is energy is proportional to frequency. So more the energy, more is the frequency. Okay, so now we come to the orbitals. Okay, we have to draw, I will just draw the 6 orbitals. The first orbital, the second one, the third one, fourth, fifth. Let me take the first one here itself. Okay, now this is n equal to 1. Okay, n equal to 2, 3, 4, 5, 6. I will just write the energy levels for hydrogen atom. So we know this is minus 13.6 E. We have written many times. En is equal to minus 13.6 divided by n square. Okay, so these are the n values. So for the first, the energy is minus 13.6. For the second case, it is minus 3.4. So it is minus 13.6 divided by 2 square, which is minus 3.4. I'm just not calculating, I've just calculated this. Minus 1.5. Then we have this as minus 0.8. We can check these values. Okay. Then this is minus 0.54 something. Then this is minus 0.4 and so on. So what we observe, as we go up, we are getting more fractions. So let us observe what happens. We want to find the photon with emits the highest frequency so if we jump from n equal to 1 to n equal to 2. Okay, so when the electron jumps from n equal to 1 to n equal to 2. Okay, so here in the first case, because it is going from 1 to 2, it won't radiate any energy. Okay, radiation occurs when, if and only if, the electron jumps from higher to lower. So this option is of course incorrect. The second case, in the second one, what we are given is from n equal to 2 to n equal to 1. Okay, so in this case, of course, we will get radiation. So in this case, the electron jump from higher orbit to lower orbit. So the difference, okay, what is the difference? Minus 13.6 minus, so this is minus 3.4 minus of minus 13.6. Okay, so if we calculate this, so what we have is 10.2 electron volt. So we get a photon having energy 10.2 electron volt. So this, I'm just writing the value here, 10.2 electron volt for this. Okay, next what we have is when from n equal to 2 to n equal to 6, okay, when it jumps from 2 to 6, okay, it is going from lower to higher, so there is no radiation in this case. And it jumps from 6 to 2, okay, 6 is this one, it jumps from 6 to 2, so the difference in energy is, what is the difference? Minus 0.4 minus of minus 3.4, so which comes out to be 3, okay, 3 electron volt. So here we have 3.4. so in all the case what we observe is this one, this radiation, okay, it gives the highest frequency. Okay, now in the question it was given highest frequency. Suppose we didn't have the lowest wavelength, okay, so highest frequency also corresponds to lowest wavelength. So instead of, if the question had been instead of highest frequency, it would have been lowest wavelength, so the same answer would be there. Okay, so in our case the answer is from n equal to 2 to n equal to. Next we come to question number 4. Which of the transitions in hydrogen atom emits a photon of lowest frequency? So here we want to find the lowest frequency. We again write the energy equation. We have the energy equation E equal to h into f. Okay, E is h into f. Okay, so more the energy, more the f, less the energy, less is f. So first I will draw the energy levels. Okay, because here the highest one is 4, so I have to draw 4 energy levels. Okay, 1 2 3 and the fourth one. Okay, so this is the n value, 1 2 3 4. Now we know this energy for hydrogen atom, for the first orbital it is minus 13.6 electron volt. Okay, the second is minus 3.4 electron volt, next is minus 1.5 electron volt, and the fourth is minus 0.8 electron volt. Okay, this we can calculate this by using the formula En is equal to minus 13.6 upon 1 n square. Okay, so first we calculate from n equal to 2 n equal to 1. Okay, now this how to calculate this from n equal to
okay students, that's all for today's session.
When the electron jumps from
So
this,
please revise
orbit
through the
to this
problems
orbit
carefully.
Okay,
All
so
the
we
best.
find the difference.
Thanks for watching.
So n2 minus n1, so n2 is, for the first case, n2 is minus 3.4 minus of minus 13.6, so this comes out to be 10.2 electron volt. Okay, so this corresponds to 10.2 electron volt. Okay, next we do the calculation for the second option. Okay, so I'm just rubbing this, I don't want this. Okay, now for the second option what we have is from 4 to 3. 4 is minus 0.8 and 3 is minus 1.5, so minus of minus 1.5, which comes out to be 0.7 electron volt. So this is 0.7 electron volt. Next from 3 to 1. Okay, so the third orbit of the energy of third orbital is 1.5, minus of minus is 13.6. okay, energy of the first one. So this comes out to be 12.1 electron volt. Okay, so this is 12.1 electron volt. And then the last one, which is from 4 to 2. Okay, 4 to 2, energy of fourth is minus 0.8 and 2 is minus 3.4, so minus of minus 3.4, which comes out to be 2.6. so this is 2.6. so we have done the calculation for all the options. Now we want to find the lowest. So lowest frequency means the energy the lowest energy difference. So this is this particular radiation, this one. Okay, it is given the least energy, so this will of course give the least frequency. So in this case answer is 0.7. remember students, the same question can be asked in the way, which of the transition in hydrogen atom emits a photon of highest wavelength. Okay, so lowest frequency also corresponds the highest wavelength. So this is the answer for the present case. Next we come to question number 5. In the lowest energy level of hydrogen atom, the electron has angular momentum. So we have different levels, okay, energy levels. So in the lowest energy level, so the angular momentum equation according to Bohr's theory, angular momentum is given by nh upon 2 pi. Now lowest energy level means n equal to 1. So when n equal to 1, what we have is h upon 2 pi. So angular momentum for the lowest energy level is h upon 2 pi. So this is the correct answer. Next we come to question number 6. The minimum energy required to excite a hydrogen atom from its ground state is. So we'll just draw the energy levels. Okay. So this is the first energy level, the second one, the third, and so on. We can draw more energy levels. Okay. So this corresponds to n equal to 1, this corresponds to n equal to 2, n equal to 3. Okay, and here we write the corresponding energy level for the hydrogen atom, 13.6, this is minus 3.4, minus 1.5, and so on. So we assume because it is already given, energy is in the electron is in this state, okay, the ground state. Okay, so at the if you want to supply energy, the minimum energy, okay, so that electron gets excited to the next level. Okay, so this is the case in the how much energy is required, minimum energy is required, so that this electron gets excited and goes to the next level. This is the most this is the minimum level. We are not calculating from n equal to 1 to n equal to 3 because it will require more energy. So we'll calculate the corresponding energy difference. So minus 3.4 minus of minus 13.6, this much energy is required. So this comes out to be 10.2 electron volt. So this answer is 10.2 electron volt. This is the minimum energy required to excite the hydrogen atom from its ground state. Next we come to question number 7. The velocity of an electron in the second orbit of sodium atom, atomic number 11, is u. The velocity of an electron in its fifth orbit will be. So we are given the velocity in the second orbit, we need to find the velocity of electron in the fifth orbit. So the equation for velocity v is given as kz upon n, okay, where z is the atomic number, n is the principal quantum number, that is the orbit number. Okay, now for the present case we are given v2. Okay, v2, okay, the velocity in the second orbit, k is constant, z is 11, and n is 2, but this is actually equal to u. According to the given problem, it is equal to u. So we find k from this equation. So k is 2u upon 11. Okay, now we are required to find v5, the velocity of the electron in the fifth orbit. So v5 would be equal to kz upon n. Okay, so I just substitute the values. K given is 2u upon 11, z is 11, and n is 5. Okay, so here 11 gets cancelled out, we are left with 2u upon 5. Okay, so 2u upon 5 is the answer for our case. Next question number 8. As per Bohr's model, the minimum energy in electron volt required to remove an electron from the ground state of a doubly ionized lithium atom, n equal to z equal to 3, is. So previously whatever problem we had done, they were concerned with hydrogen atom. Now we are concerning, this is problem with some not hydrogen atom, it is a lithium atom. So for such atoms, okay, the energy in general, En, okay, En is given by minus 13.6 upon n square into z square. This is what the in general term is. Okay, for hydrogen atom we write z square, is because z is 1, so we don't write this term, but this is the general expression. Now for our case, what we are given is z. Okay, so ground state means n equal to 1. Okay, and z is 3. Okay, so 3 square, so minus 13.6 into 3 square is 9. So you multiply this two. Okay, so what we get is around minus 122.4 electron volt, this much energy. Okay, so this is negative, so we must supply, okay, to remove the electron in this particular ground state, the energy required is plus 122.4 electron volt. Okay, so it is already posing minus 122, so we must supply plus 122.4 electron volt energy to remove that electron from the ground state of the lithium atom. So this is the answer. Okay students, that's all for today's session. So please revise, do the problems carefully. All the best. Thanks for watching.